Hi guys, I'm going to go over all 6 questions from the review, and your homework is to look at what I do when I go over them, check your answers, and then we'll go over them to start class tomorrow. And we'll kind of figure out if we're going to do the quiz after or to start class Wednesday. All right, so the first question is a reflection over the y-axis. Y-axis tells us substitute negative x in for x. All right, because when you reflect over the y-axis, you take opposite of x. So g of x is now negative 8 times negative x, which a negative times negative gives you positive 8x. So hopefully the first one was easy for you guys. So that was the first question, right? If you reflect over the x-axis, you take the opposite of all terms, right? That's the difference between x and y. All right, now the second question, right? Your formula is the transformation g of x is equal to a times, right, your function, whatever it is, x minus h to the n power plus k. All right. The h tells us left or right. The k tells us up or down. And right, our a tells us a multitude of things, but right, it could be a vertical stretch or a compression or a reflection if it's negative. But as you can see in this function, right, all we have is an h value of 6, right, positive 6, remember, because it's x minus h, and a k value of negative 5. So in order to graph this, right, we just move our vertex to the right 6 and down 5. So right 6, down 5, right, from our original 0, 0. So your vertex here is just h comma k, right, or 6, negative 5. So we go to 6, negative 5, we plot that point. That's your vertex. Now, you don't have a vertical stretch or compression, so it should be, if that was your new vertex and you kind of thought of that as 0, 0, your next point would be 1, 1, which in this turn would be 7, negative 4, right? Because up 1 to the right one would be 7, negative 4. Then same thing. But if you can't figure that out, right, you can always substitute values into the right or left of your vertex. So say you didn't understand that and you wanted to substitute 7 in, right, you get x, sorry, not x, you get 7 minus 6 squared minus 5 when you substitute into the function, right? So you get 1 squared minus 5, or 1 minus 5, which is negative 4. So 7, negative 4. It's right here. Right, you know you're going to have a symmetric point at 5, negative 4, right, because of the axis of symmetry. And then if you wanted to test another one, right, x equals 8. Right, so you get 7, no, not 7, 8 minus 6 squared minus 5. So you get 2 squared, which is 4 minus 5, or negative 1. So 8, negative 1 is your other point. So 8, negative 1. And the symmetric point to this would be 2 to the left of a vertex, so 4, and then same y value, negative 1. Okay, and then you make your curve. Okay, so that's how we graph that one. Now, number 3, you're looking for the function, right? So again, we need our g of x equals a times x minus h. And this is a parabola, so you know it's going to be x minus h to the second power plus k. So you just got to figure out what your vertex is, and that will give you your h comma k. right? So vertex is right here, which is at 3, 2. So your h is 3, your k is 2. So we get x minus, right? Our h is 3 squared, and then our k is positive 2, so plus 2. And now you could test for your a value, but hopefully you'll notice, right, your next point is up 1 to the right 1, which means there's no vertical stretch or compression, right? That's our normal x squared. We just moved the vertex, right? And if you went to the right, it should be up 4, which we to the right up 4. So right, that would be your function right here, right? There would be no a value because there's no stretch or compression or reflection over the x-axis. So that would be your answer, right? If you didn't believe that a was 1, you could obviously substitute an x and a y value, right? You could pick any x, y on the function, right? So if you did want to test, right, and you looked at a point, right, say we wanted to use point, there's a point right here, so we could use, say, not negative 1, 6, right? So you would substitute x in for 1 in for x, 6 in for y, so 6 equals a times x, which is 1, minus h, which we said is 3, squared, plus k, which is 2. So all I did was substitute into this, right? And then we solve for a, so we get 6 equals, you get negative 2 squared, which is 4a, plus 2. And then so you get 4 equals 4a. So you can see a equals 1, right? So if you didn't trust that it was just the x squared function with a moved vertex, then you can test for a by always substituting an x and y value with your h and k there and solve for a. All right, so that is number 3. Number 4 is the first piecewise. So you just got to graph each line. Okay, so the first one, right, we have x plus 1, right? And it's when x is less than negative 1. So we're going to pick x equals negative 1 to substitute in. Right, we always pick one. If we only have one endpoint, we always pick that endpoint. Now, because it's less than, we need to pick a number less than negative 1. So we can do x equals negative 2. Okay, so your function is x plus 1. So negative 1 plus 1, right, is 0. So 1 point is negative 1, 0. If you substitute in negative 2, you get negative 2 plus 1, which is negative 1. So negative 2, negative 1 is a point. Right, so we can plot this one, the negative 1, 0, but remember it's a open circle at negative 1, 0. So I just did it wrong because I filled it in, right? Open circle there. And then this one is going to be closed because it's part of our line. So negative 2, negative 1 is right here. And then you just make that line going on left forever because its x is less than negative 1. So that's our first one. Our second one, same exact thing, except we substitute in a number to the right of negative 1 because it's greater than or equal to negative 1. So x equals negative 1, right? We know this is going to be a closed circle there. So negative 2 times negative 1 plus 1. Right? Negative 2 times negative 1 is 2, plus 1 is 3. So negative 1, 3. Remember, it's closed there. So negative 1, 3 is closed. And then if I pick a number to the right, negative 2 is right. So negative 2, not negative 2. 0 is to the right. Negative 2 times 0 plus 1 is just 1. So 0, 1 is on our graph. So you find 0, 1, and then we make that line, right? And it makes sense. It has a negative slope, so it should be going down and to the right. So that's how we graph this function. All right, number 5, right? You're coming up with a rule, right? Both end at x equals 0. Okay, so this function right here on the right side is going to be x is, now because it doesn't tell you exactly, right, You can, one will be greater than, or you can say greater than or equal to. All right, I'll just use greater than, but like I said, the other one will have to be included. We're not sure which one's included and which one's not included. So x is greater than 0, and then this side would be x is less than or equal to 0. Now, I'll accept it both ways. If you said x is greater than or equal to 0 and x is just less than 0, same thing. All right, so our right side we'll say is just greater than 0. Left side is less than or equal to 0. Now we just got to find our slope, right? So the line over here, right, has a slope of up 1 to the right 1. So this is m equals 1. And then our y-intercept is our b value, which is -3. Okay, so this function is, remember, it's y equals mx plus b. So our m is 1, so we just have an x, and our b is -3, so -3 is our function. Now the left side, we have the same b, right? B is still -3, but our slope is up 1 to the left 1, so slope is -1. So this one would be -x minus 3, right? Because -1 is your slope, so that's what you substitute in for m, and then your b is still -3. And that is the rule to our g of x function, or f of x function. All right, and then one more. All right, last one. All right, you have to graph 3 lines. Okay, so it's very similar to number 4, except there's an extra line there. Right, the easiest one to honestly start with is, right, y equals 2 line. It's from -4 to 5. So we find y equals 2, right? We make a closed circle at -4 because it's less than or equal to, and a closed circle at 5. And so our straight horizontal line is only from -4 to +5 at y equals 2. Now the other ones you got to do a little substituting in, right? So this one again, it should be open at -4. So -x minus 4. We use x equals -4. And then you can substitute any value to the left because it's less than. So x equals -5 is good. Where the other one, right, 2x, we have x is greater than 5, so open circle at 5, whatever you get, and then a point to the right of 5, which is just 6. So substitute in, we get opposite of -4, because we substitute -4 just in for x, so we get +4 minus 4 is 0. -4 is 0. So -4 is 0 is right here with the open circle. And then -5. All right, so substitute -5 in. So opposite of -5 minus 4. So you get +5 minus 4, which is 1. So -5, 1. And then you make that line going on forever. Last one, 2x. So 2 times 5 is 10. So 510. So 510 has an open circle. Oh, that's a large circle. 510. And then 6, right, is just going to be 12 because 2 times 6 is 12. So 612. And then you can make the line going on forever. All right, so that's all 6 questions. I want you to watch this whole video and review this, and then we'll go over these answers again in person tomorrow. Okay? So have a good night. Please do this for homework. Thank you.